Hey everybody. As you can tell, I've got a weird voice, so don't let that throw you off. But This is the first video out of the set of three videos for the section 9.2, 9.4, and 9.5. This one is the piecewise function. Piecewise functions one. So remember for this for this choice board, you're going to have three sets of videos, three sets of assignments, and then check two of them, and then we're going to review for overall three. So piecewise functions. It's a new type of function that it kind of puts parts together, and I'll show you what I mean there in a second. Here's our definition. Piecewise function is a function that is a combination of one or more functions. That's basically what it is. If you want to stick two different functions together, you call that a piecewise function. You put pieces and parts of them together. The cool thing here is it can be different for each parts of the different domain. So you can say, for if x is between this and this, then you follow this rule. If x is between this and this, then you follow this rule. Think about the book gives here this movie ticket example. For instance, movie ticket prices are often different for a different age group. So the function for movie ticket prices would assign a different value for the different age level, right? Think about, and I don't know, I don't think, movie ticket prices do this anymore. Well, maybe they do. But if you're under a certain amount of age, then you may cost less. But if you're, average age, then it costs this much. But once you get to a certain age, maybe you're a senior citizen, maybe they give you a discount for senior citizens, it costs a little bit less. So, different ages would require a different price, so that each age group gets you a different price. I thought there was a graph down there, but I guess there's not. Don't forget about interval notation. Remember, you might use interval notation here. So don't forget, brackets mean you include something. Parentheses means you do not include something. So just as a reminder for that. So think about this. For any of you golfers out there, greens fees is basically like the price to go golfing, right? So say you go to a golf course. They're going to charge you a different price based on the time that you start golfing. Okay. Think about this, and really, I'm just going to talk through this, because creating a table and a verbal description, I could write out my verbal description, but we'll just talk about it. So think about what's happening here. Basically here, if I start golfing at 8 a.m., what's my price? Well, looks like this is going up by threes each line there, 21, 24, 27, 28. Maybe it's $28 if you start golfing, and this will be my table, if you start golfing from 8 to noon. But once it hits noon, the price drops a little bit. How much does it drop to? Drops to $24. And that goes till 4 p.m. Once it hits 4 p.m., though, it goes from $24 all the way down to $12. And that's from 4 p.m. on, right? So, think about why that's happening. Well, if you're golfing, everybody wants to go golfing in the morning, get going off early in the morning, get stuff done later in the day. Then knocks it down a little bit. The course is not so busy, noon. And then once it hits 4, it's going to get dark pretty soon. Nobody wants to go later in the day. You want to go home, go to dinner. So from 4 on, they just knock the price down a lot to entice the cheapskates to go golfing. So I like to go golfing during this time period because I'm a cheapie. But if I'm going out, I want to have a nice day, and I'm going out with my friends and plan on it early, and we pick a day and we plan to do stuff later in the day. Yeah, sure, I'll pay the extra money and go out early, So this is the type of piecewise function. This is also called a step function. That particular one is called a step function. Notice why? Because of the steps, right? Each part of my function, each piece of my function is a step. a horizontal line. Okay. Greens fees, that ticket price thing, it's a step function. This is actually what a piecewise function will look like. Okay. So here's our function. We name it something. It's equal to, and then we have this brace, and that's going to go around all parts of our intervals. Now think about, look at our intervals. From 0 to 13, from 13 to 55, 55 on. This would probably be like my movie ticket price thing. Okay, if you're between 0 and 13, if you're under 13, then you're going to pay $5. If you're between 13 and 55, you're going to pay $9. If you're greater than 55, if you're older than 55, you're going to pay $6.50. This is what a piecewise function looks like. It gives you your domain, and it says, okay, find out which part of your domain you're in. That part of the domain will tell you your output. See where your input is. The output will follow. Okay, that's what any piecewise function, right? Obviously, f of x is 5 if x is greater than 0 and less than 13. We talked about that already. I don't have to read that out loud to you guys. Don't waste time there. We talked about this. To evaluate, you look for the input and see where it goes. Okay, so let's take a look here. Nope, looks like my thing's going off the page here. Okay. Evaluate each piecewise function for x equals 1, -1, 4, and 2. So let's think about where does this go? Okay, so at -1, remember that's our notation for -1. You look, okay, where is my domain? Where's my domain? Well, -1, is it less than or equal to 2? Yes, that means I use this rule. I'm going to use the 2x plus 1 rule. See, I find my domain, I use that specific output for that domain. So f of -1 is -2 plus 1. So f of -1 is -1, right? My output for -1 would be -1. Think about 4, f of 4. Okay, so if x is less than or equal to 2, I use this rule. If x is greater than 2, I use this rule. Is x greater than 2? Yeah, so I'm going to use this rule instead of the other rule. So I would use so I ignore the linear part of it. Now I'm looking at this parabolic part of it. So 4 squared minus 4, or 16 minus 4, or 12. So f of 4 is 12. Okay, so think about, oh, I'm using f, but this really should be h, so don't mind me there. So in the last one, f of 2. Okay, now looking at 2, it looks like it might follow both those rules, but look, here's my or equal to. So I jump here. I use the 2x plus 1 rule. 2 times 2 plus 1. Oops. F of 2 is 5. There's my answer. Excuse all the coughing. All right, now that would not be considered a step function. Why not? Because this is linear and this is quadratic. Because none of these are just horizontal lines, none of these are constant values, this is not a step function anymore. We would call that a piecewise function. A step function is a type of piecewise function, but it's only a horizontal line piecewise function. So, all right. Now, think about how I would graph this. So let's take a look here. There are two pieces to this. There are going to be two parts that I graph this with. Think about the parts that are happening here, though. This would be a step function. Okay, if x is less than or equal to -1, now think about where that happens in terms of my x values, my left and right values. So if x is less than -1, so here's my cutoff line. I'm going to put in this dotted line, but then erase it away here in a minute. All right, so there's my cutoff line. If x is less than or equal to -1, then my y value is 4. If x is greater than -1, then my y value is -2. Notice that I did there with my open and closed circles. Then I'm just going to go in and erase this away. You don't have to draw that dotted line in there because you are going to erase it away eventually, but that's what that should look like. Or equal to's get the closed dot, greater than just gets the open dot. Okay, and think about that. Your boundary line is always a vertical line of where these things cross or where this thing stops. So what if it's not just a step function anymore? What if it's a true piecewise like this? Well, see where it stops. Okay, it's 0. Okay, so what's going on left of 0 when x is less than 0? Well, it looks like 1/4 x plus 3. Okay, so y-intercept of positive 3. And my slope is 1/4. So rise 1, run 4. Don't put it over there. Remember, I want less than 0. Down 1, left 4. Okay, that's my line. Yeah, it would continue over there, but it doesn't continue over there because it's only to the left. That should be an open circle too. Okay, now let's take a look here. Negative 2x plus 3. Oh my gosh, I should have left it as a closed circle because look, there's my y-intercept of positive 3. Fills in that dot. Down 2, right 1. Down 2, right 1. And so on. Do not continue on toward the negative part of the graph because I only want x values for greater than or equal to 0. And there's my line. Okay. There's that. Keep chugging along. So that last piecewise function was continuous. Why? Because there was no gaps or breaks in this. This one was continuous as well because there's still no gaps or breaks. Everything is defined. But know that it doesn't have to be continuous. They're not necessarily continuous. They don't have to be continuous. If there's parts that are left out of my bracket, then you literally just leave a space there, okay? Okay, to write the rule, that's what we're going to look at next. To write the rule for the piecewise function, determine where the domain is divided and write separate rules for each piece, okay? Looking at separate rules for each piece. So, got this word problem here. Shelly earns $8 an hour. She earns $12 an hour for each hour over 40 that she works. Okay, so that's going to tell me everything that I need to know. Okay, so here's my function. Okay, so for x is greater than, oops, that's a less than symbol. For x is greater than 40, and actually, you know what? It says up to 60, so I'm actually going to cap it at 62. And greater than 40. For any hour less than 40, oh, and they both can't be equal to. Well, let's leave the, yeah, let's go here. Let's take that or equal to off, and we'll just have to write our rules accordingly. Let's move these guys over a little bit. Give us some space. All right, she earns $12 an hour. I'm sorry, $8 an hour. 8x for all of that, if x is less than or equal to 40, right? Okay, so what happens at 40? Well, she gets overtime pay, right? She gets overtime pay. Now, I bet you're tempted to just say 12x here. Yes and no, okay? Yes and no. Because if I get, I'm not making $12 an hour on all of my 40 hours. Or I'm sorry, all of my, say I worked like 50 hours. I'm not making $12 an hour on all of my 50 hours. I'm only making $12 an hour on 10 of those hours, right? So we have to change our answer accordingly. Okay, so think about, well, how much do I make if I make $40 an hour times 40? $320. So in addition to that $320, in addition to that $40 an hour, I'm going to make $12 for every hour over 40 that I work. X minus 40. So let's test out our rule. Excuse me for all the coughing. Say I work 50 hours. Okay, so that would kicks down here. I make $320 plus $12 for 10 total hours there. Is that true? Yes. Okay, so there's my good function. Okay, so we have 8x. So for everything up to 40. So here's my cutoff line. All right, so 0, 0, and going up to, well, that was 40, 320. Right, so somewhere around right there. This one is also going to be a continuous. Let me get this out of here. But now it's going to go up to $12 an hour. So say I did have 5320 plus 12 times 10, right? Because that was, not 110. 440. So 50, 440. Somewhere like that. So it's going to be a little bit steeper line. Oh, and it set up to 60. So what was it going to be at 60? 320 plus 12 times 20. 560. So it should have been like right there. Oops. There we go. That's a straight line. Follow me there, right? Okay. All right. All right. Let's take a look here. Write the piecewise function. Pause and see if you can figure out. This is the last one, so try if you can figure out that piecewise function. See where it's stopping. All right. So we got f of x is equal to. Okay. So where's my cutting off point? I've got something less than. Here it is. 1. For x is less than 1, and then something for x is greater than or equal to 1, right? Because I have my closed out there. So what x is less than 1? Well, it goes through 0, 0, so it's a y-intercept is 0. What's my slope? Rise 1, 2, 3, run 1. So it's a negative sloping rise 3, run 1. So negative 3x. That's this piece here. Okay, so now I can't see my y-intercept, but if I did, would that follow there? Excuse me. All right, so what would be my y-intercept? Looks like I've got 3, comma. It's like that crosses nicely and that crosses nicely. So 3, comma, what is that? 5. And then I've got 4, comma, let's estimate that to be 7. 4, comma 7, right? So I'm rising, because look, they're going up by 2s. I'm rising 1 and running 2, right? 3. Oh, that's why. I'm like, they're going up by 2s. So sorry about that. Okay. Yeah. So this would actually be a 2, 5. That's why. Knew something was messed up there. 2, comma 5, and that would be what would this be? 2, comma 5. And then a 3, comma, actually, let's just do this. Let's just say get away there. 4, comma 7. Okay, so now look, how much am I rising? 2, running 2. Right, and that's a positive sloping line. Okay, so that means I've got a 1x, right? I've got a 1x. And then what would be my y-intercept? Well, if this continued down 1, left 1, down 1, left 1, it looks like it would be at positive 3. So x plus 3, right? Would that make all of that? Well, let's take a look and see. This should be like a 4, 6, comma 9, maybe? 6, comma 9. Yep, that would work out. Here's my function. All right. Thanks for watching, folks.